Hi everyone, I continue with this topic is Cisco excels in wide area networks, connecting different sites over telephone company circuits. To many people, a T1 or TS3 connection is some mysterious thing that provides the internet or connect corporate offices to headquarters. When you know a little about them, however, network circuits are far less mysterious than whatever makes your boss computer crash three times a day. Wide area networks are mainly used for connections to the internet via an ISP or for connecting two offices over a private network. We discuss both uses. In the first point is internet connection. Chances are good that readers of this book were handed the office internet connection when they installed. Here, take care of this. Maybe this inherited internet connection works flawlessly and silently. However, if you are in the market of a new internet connection, or if you want to replace the atrocity of a circuit you currently endure, read on. You have a large variety of ISPs to choose from and a bewildering variety of service packages. It can be difficult to sort them all out, but here are some tips to help you decide. Choosing an ISP. Choosing an internet circuit is difficult when compared to, say, buy a car. When you need a car, you have some idea of your requirements. You know how many people you have to haul around, how often you need to move large objects, and what sort of comfort features you want. And you can integrate all this and make a vaguely intelligent decision between the sub and the subcompact. To make an informed choice about network bandwidth, you need the same sort of information. You need to know how much bandwidth your company actually uses. You can get a vague idea from random spot checks of throughput on the serial interface on your router's current internet circuit. But this is unreliable. You can easily miss random peaks. Your best bet is to use a tool like MRTG to gather statistics on your bandwidth usage over days or weeks. Even if you are not in a decision-making position, you know how much bandwidth your company uses will help your decision makes and will also make you look good. No matter how much bandwidth you have, at some times your company will consume all of it. For example, downloading an ISO image from a high bandwidth site can swap up an entire T1 for several minutes and smaller circuits for proportionality longer. But consider this: how often do you use all of your bandwidth, and how urgent are those high volume requests? When you do need to download an entire ISO, do you need it in 10 minutes or will an hour suffice? In my experience working for ISPs, most companies that purchase a T1 use less than a tenth of their bandwidth 99% of the time. If you know that the 128 kilobytes per second you want more than meet your company's needs, you will be completely justified in lowing when a salesperson attempts to sell you three bonded T1s with light failover for 4.5 megabytes per second. of high quality throughput. It sounds great, but you probably don't need it. When you know what you need, you can easily gather a list of providers in your area from any search engine. Make a list of those who provide the service you require, and then start wending the out. Talk to network staff at other companies. Ask who they get internet service through and how satisfied they are. Look for complaints in public news groups and websites. While every company has a few dissatisfied customers, though the number of complaints about any one company seems excessive compared to the others. See what you think. After you weeded out the obviously loser from your list, you can group the reminders into four categories. The first category is big telcos. These are companies like SBC and Quest who have big names and correspondingly big prices. They frequently offer high level of service because they own the phone circuit as well as the internet service. These companies can be difficult to work with when, when things go wrong. However, especially for small customers, getting unusual problems resolved can take quite some time. You can frequently improve your price and service from one of these by going through a reseller such as bandwidth.com. The next category is national ISP. These are big internet companies such as Level 3. Many times, these companies have unadvertised links to a big telco. Because they are poor internet companies, they frequently have a better understanding of the internet, unique requirements and technology than telco-based ISPs. These companies will frequently carry your traffic across the country to get it to someone on the other side of town simply because that's their closest connection to the other person's provider. The next category is regional ISP. These are local companies that cover a city, a state, or a few states. While they are generally clients of the telcos and national ISPs, they have a variety of connections in variety of locations to a variety of providers. Some of these companies have excellent customer service, while others have service that is not so good. Regional ISP are frequently more flexible than larger ones and have the technical staff to back it up. And the last category is mom and pop ISPs. It's perfectly feasible for someone to set up a medium-sized router in his basement and start selling T1s. These companies can be inexpensive and fairly reliable. The mom and pop's ISP doesn't have a huge number of customers, so it cares about each and everyone it has. Frequently, the ISPs are underfunded and under-equipment, which can be a risk, but their prices are good, and they usually don't flinch from special requests. Having been employed by all four types, I have to say that my favorite is a good regional ISP. Your experience in your area might vary. The next point is ISP router configuration. Your ISP should help configure your router or at least provide a configuration for the interface connecting to them. For the most part, you can accept what they give you. They are in the business of connecting customers to the internet every day, and you are in the business of connecting this solary T1 as soon as possible. If you are going to build a configuration by hand, however, ask for this information. In the first point is serial interface IP address. Most ISPs give HN of a T1 and IP address and assign a block of 4 IP addresses with a net mask of this direction. To the circuit network, the bottom and top IP address in the block are not usable. One of the remaining addresses is assigned to each end of the circuit. You must know which IP goes on each end in order to configure your router appropriately. While you can use a serial line without an IP address, doing so will make troubleshooting and sophisticated routing more difficult. The next point is circuit ID or customer number. If you should have a T1 failure, you will need to contact the ISPs in a hurry. Get the circuit ID for this circuit and or your ISP's customer's number for your company so that you have this information handy when you call. The next point is T1 line encapsulation. Every circuit has an encapsulation setting. Common choice are HDLC and triple P point-to-point protocol, discussed in Chapter 3. As long as both your router and your ISP router use the same encapsulation protocol, the circuit will work. In the last point is Ethernet IP addresses. Every client of an ISP should get a block of IP addresses for machines of their network. Usually, these addresses are assigned to firewalls, desktop machines, or other computers. With the prevalence of network address transmission, translation, NAT, and proxy firewalls, this block may be as small as 8 IP addresses. Your job is to decide which address in the block will be assigned to your router's Ethernet interface. Usually the first or last usable address is the block. As soon as you have this information, you can configure your router to connect to your ISP. The first step is to log into the router and enter configure mode. We discuss each of the following entries in Chapter 3, but basically by setting an IP address and an encapsulation protocol, you should bring your circuit up. Okay, and terminal, config terminal, in serial interface name, description with the name of ISP, circuit ID, and customer number. And encapsulation, IP address, and netmask, and exit. After you enter the above commands, your T1 should show a status and line protocol of up, being the ISP side of the T1 line, and you should get a response. When you do, you know that your T1 is up, save your work immediately. Write memory. Now configure the router's Ethernet interfaces. Okay. In this case, I use the router ISR 4331 with, I don't know, with this router is the same, but This is router 1 and this is router ISP, Internet Service Provider. Okay, in this case I connect with Cooper Stream with crossover. Use the console, auxiliary console, Gigabyte Ethernet, and here, and Gigabyte Ethernet. Okay. In the CLI, now enable router name ISP config terminal name ISP. I don't remember how to change the name, but okay. Exit and show interfaces. The first interface is Gigabit Ethernet 0/0/0/0/. Okay, and router 1, enter, enable, and show interfaces. Okay. Sorry. Okay, but router 1 and ISP has the same interfaces. In this case, the interface of ISP I configure is with config terminal with interface Gigabit Ethernet 0/0/0/. Okay. Config serial interface. With protocol. Okay. I search the protocol encapsulation, sorry. Encap Okay, router config. Okay, exit. I need active. And gigabits. Okay, this practice is for the next one. See you later.